Hello everybody, my name is Rasmus. I am with Group as a Senior DevOps Architect, and I am running a session today on what came first, chicken, the egg, or GitOps. This is sort of a presentation and a half, as I have an existing concept that I lovingly termed Hobo GitOps, which is kind of like GitOps for the rest of us. GitOps has of course been a big thing now for a while. There are lots of definitions by it, but unless you're really well positioned where you can run everything Kubernetes, you're probably not using it the right way or the true way. So I came up with some ideas and thoughts on how to make it work for everybody else. So today's target audience is large enterprises or just the GitOps curious. So this could be you're working in a complex workplace and you just need a lot of complexity to keep things running. Or it could just be that you're a developer who's just curious, hey, I really want more control over how my thing is deployed by the ops people, or understand better how their stuff is running so I can test it accurately locally rather than have it work completely differently when it finally goes to the cloud somewhere. So the problem today is, as I said, not everybody can use fancy GitOps, true GitOps, where everything is just perfect. You're using modern tools, everything is awesome. You have no tech debt. Congratulations. No, that's just not reality for most of us. Far more likely is that the maturity varies between all the kinds of different teams in your workplace. That, it's great to do the things, but you have priorities and deadlines and budgets and things, so you don't know. There's so many tools. You could be using all kinds of things. If you're a large place, you might be using all the things in the same place because, well, different teams like different things, and if you start really, Wild West-ish, then it might become a mess before you need to make it better. Lots of teams use different things, so we need to get somewhere better together. Some aren't even using Docker still today, or on bare metal. So what can GitOps do for me as a caveman? The solution for me is, as I've said, Hobo GitOps, which is a thought that, yeah, teams are different. They are all kinds of shapes and sizes and maturity levels. They come and go. We need some sort of framework that will help everybody move towards a better solution, even if we kind of know that not everybody will ever get there. So I have a small selection of use cases here, which is just, setting up that, yep, different teams do different things. Amongst this little group here, only Alice is truly using GitOps because her team is fully on Kubernetes. They're using the WeWorks Flux GitOps operator, and their CS system is running over heavily customized Jenkins. They've done this stuff for years and they're good at it. Cool. The other teams, not so much. They're in a variety of, I don't know what I'm doing. Well, it's VMware and Jenkins agents for deploys. And, well, maybe you have some rebels who just say, hey, I know how to do the thing. Just let me do the thing. I don't need all this stuff. But, again, the enterprise likes people moving together forward and getting to the same place. So, what is GitOps and how do hobos relate? If we define it as per what WeWorks originally defined it as, it is a thing where rather than the traditional piece where you might have a Jenkins or some other tool that does both your CI and then it has deploy jobs that deploys them somewhere, or you're using Ansible or Chef or something else where you're pushing out change from some sort of central workspace, and either that's going to exist in a Jenkins or it's run locally or who knows. Rather than do that thing where it goes all the way from dev into a cluster, there we go, where you can just write to the cluster and anybody with access can do whatever they want and things go crazy at Wild West and who knows where it's going to go. So with GitOps, you put a wall to where the developers can check in code, CI can read it and put images up in a repo, but there's no access into the actual cluster or wherever your stuff lives. There is, however, a configuration repository, which a GitOps operator is looking at. This would be changed by developers or ops or something like that to say, okay, it's time to release version 1.2.3. Make a pull request to this thing, and the moment you merge it, this operator goes and sees, oh, there's a change. I need to apply this. And then it converges the cluster as per whatever is in your actual configuration repository. There's a bunch of extra links here in case you're curious to read up on the concepts as per GitOps, as per Weaveworks. There are a lot of different interpretations already. GitOps is the latest new, buzzword and so on. So we're doing GitOps can mean absolutely nothing at all. The real critical part, to me at least, is that nothing has access to the cluster. The cluster is using a pull effect, where it's dragging things out that is being updated, and then it converts based on whatever it is. And this is usually a Git repository, and you're usually updating this by using pull requests that indicate here's a released change. So, how does GitOps compare with the old-fashioned infrastructure as code, IAC? IAC, of course, does use version control for your infrastructure. So you might have cookbooks in there. It can be used on just about anything, because ultimately you or some proxy version of you, like a CI/CD system, is applying these things directly to whatever the target hosting is. It's a push effect. You provision stuff out of SCMS source of truth. You may use these tools like Public Ship Ansible. But again, convergence is triggered by some process it's being pushed in. It can segregate access to a point, but it doesn't have the same thing that GitOps has, where there's a very definite line to here and no further. So GitOps is an opinionated version of IAC. It's in its true form, it's meant to be cloud native. It's meant to run in Kubernetes in some flavor or another, something where you have actual state of the infrastructure in config files and something that knows, oh, I'm going to take the things, put them in there, and make it look like that. There's no direct actions. You only modify things in SCM, and then the GitOps operator goes and sees, aha, I need to do a thing, and then it converts your infrastructure. There's very strong access segregation here because you're using Git in sort of allowing it to be a hole in the wall, insofar that it comes in, like changes come in from one side, they sit there in the wall, and then the other side goes and pulls it out and affects it to your infrastructure. Another thing that Weaveworks likes to point out is that GitOps is not CI-ops. That is to say, you keep those two separate. You do your CI in one place, you do your CD in another place. They don't connect. They just, hand over things through middleware or whatnot somewhere in the middle. There's a very strong separation. No old school Jenkins deploy jobs. I've used them, I love them. They're appropriate in some cases, but it's not GitOps. There's another article here, some anti-patterns and good things. How does GitOps then compare to Hobo GitOps? Well, Hobo GitOps kind of works in two layers of sorts. There's one layer where it uses IAC for configuring a Jenkins, which is the Hobo operator in this case. So there's some utility jobs in there that the developers using the process can go and use and do things, and that's one layer. The other layer is, okay, when you have this set up and you're ready and you're happy with it, you have some application manifests, which are being read by Jenkins as a Hobo operator, and then Jenkins goes and deploys the thing to wherever it is. So you do get deploy jobs, but there is an attempt at a separation between the two. It ideally uses Docker. It could be using Kubernetes, but it could also really be wrapping something else like AMIs and AWS or VMs or even just a bunch of shell scripts. There's a spectrum between direct access and full automation, in that developers might be able to do some things at the dev tier directly, but then when they get to production, nope, you can't go any further. You have to follow the process and trigger things with GitOps. The utility jobs in Jenkins are automated with Job DSL, which is just the way of writing Jenkins jobs in a DSL language in Groovy. And instead it uses tiers, so there's dev and QA and prod by default. You can make as many as you want, and changes propagate between them through source control. So you have a pull request between dev and QA, and when it gets merged, your QA Jenkins will do its CD thing and hit the target environment. That allows a segregation of access between the tiers, because you can give devs access to the dev tier, you can give QA access to the QA tier, and you can give nobody access to the production tier, so that only things that go in through GitOps will actually get in there. It does this by providing hooks for these teams to write their DSL stuff against. They're really providing the deploy logic inside this, and you're providing the resources that the logic will be able to apply its thing to. It could support teams using true GitOps. That's sort of a point where you do the Hobo GitOps thing to update a repository over here, which actually has a real true GitOps operator looking at it and pulling in changes. That's an awkward situation. It has been called for, I've seen it, but it's not a technical requirement. It's just if you have a particularly political or red tapey type environment, you might need several layers where you can do things differently. I like to suggest that GitOps hobos live under the on-ramp that leads to true GitOps adoption. You may or may not get there, but at least you're on the right direction. The tools for hobo GitOps, at least, is Jenkins, because Jenkins is still the king of flexibility, is the gold standard of CI at least, and it has been abused for CD for years. It has been used for anything. You can load your toaster with it, you can run your lava lamps. It's Jenkins. It's a Swiss Army knife, but that also means that it can get sharp and rusty in places. I have a bunch of repositories here that show a demo approach of how this works, where you have this job DSL powering your utility jobs and a manifest that defines your application, and then the utility jobs goes and says, okay, I'm going to deploy this based on the manifest and make the environment look like this for me. Cool. There is a local workspace to where you can write these DSL scripts and in general maintain Jenkins. So that's writing your init scripts, figuring out what plugins go in where, and just kind of all around useful thing for working with Jenkins. Now, as far as the complexity goes that you can model with this kind of thing, in a small shop, you don't need a lot. You might just have a single Jenkins master, you're a small starting team, and you start playing with the idea of infrastructure as code, you start playing with Jenkins development, testing it, you get into scripting your pipelines and pipeline libraries and scripts and so on. Good stuff, it's fine. As you grow, you might get more teams where you want to distinguish between them so that Team X doesn't bowl over something Team Y is doing, which sometimes can happen. Yet you can still get shared utility out of keeping your job DSL in centralized repository, and you can still hand out power to where teams can still configure their masters and do their things. So there you have one per team. When it gets really complicated or political, red tape, and so on, you might not want to have access from one Jenkins to everything. This is a very typical pattern where you just have, okay, Jenkins can deploy. Are you deploying to dev or QA or production? Just pick the option from the drop down, hit the button, you're done, you go. But some people are worried about how that opens up a dev Jenkins that can reach into a production environment, which would be bad. So in this tiered approach, we're splitting that apart to where you have a little mini simple CD Jenkins in addition to your build tier Jenkins that goes in there, and dev tier can reach dev, QA tier can reach QA, prod tier can reach prod. But then you can access, segregate, and determine who can reach each of those masters. So that helps. It can start you on GitOps because you can do pull requests between these tiers through manifests. And whenever you merge it, well, the next one sees, okay, I'm supposed to merge the thing. Okay, GitOps, yay. Don't get down here. This is imagining experience. It is hard to come back from this. Not impossible, but if your infrastructure looks at all like this, or it makes you smile, then you need help. And maybe you can get the help from this thing or other tools, but this place you can get back. You can start formalizing things by using manifest. You can start reusing, identifying what can be reused. Maybe this Jenkins over here is particularly useful. Maybe stuff from there can go somewhere central where it can be slowly applied to other Jenkinses or new shiny ones that come up when you're ready for it. All right. So going back to our teams here a little bit again to see what they can do. Alice is ahead. She's the one who's doing full-on Kubernetes, GitOps, the real way, and everything. And hopefully that team is freed up a little bit to think about how they can better share all their cool powers and so on. So that's Like they have a heavily customized Jenkins. Okay, can you share it? What about putting some of that stuff in Git so it can be applied automatically to other people's Jenkins Masters? Cool. They could stop this, generic DSL utility stuff from all their cool things and begin sharing out these manifest repositories so that you can also use them for CI and for other teams and so on. And they could probably help figure out, well, if somebody else wants to do true GitOps, what kind of hook do you need? I mean, how do you need to structure your applications for it? What can you do to help others improve? Then we have Bob, who doesn't really know what his stuff does, where it lives or anything, but it doesn't have to be complicated. It doesn't have to be as fancy as Alice's thing. You can just start with a fresh, new lowest denominator, build Jenkins, which just knows how to, set up your website and run some sort of linting process on it. Small things, so that it'll be put on a nice little UI with some graphs and charts and fun things that can be shown to people and saying, hey, look how better it got the last few releases. Cool. And you can get to the point where at least you can document and start plugging in where your code is, where is it going, what environments exist. Basics. Donnie dances close to the fire, and I think I skipped Carol. There she is. Okay, so Carol is doing decently. She's somewhere in the mid-range, using VMs and deploy Jenkins and so on. So that's where you can start, okay, let's try to formalize some build stages and adopt changes from Alice and other good things. Start defining things in tiers, so it's not just all like a bunch of Jenkins deploy agents all sitting on a single master that just can reach into all the different environments. That helps you get segregated access and version your release better and just start getting rid of the future. Now, back to Donnie. He's the rebel. He really just wants to do the things. And if you're okay with that, okay, it's your business. But, maybe if some structure was in place, there would be fewer whoops moments. So, help out. Add in some neat Docker-heavy CI analytics and things that you can add in there and start preparing the path to get to Kubernetes. Maybe he can work with Alice on that cool GitOps operator they're working on, and it'll be even less work. That'd be cool. So that's kind of the abstract. These are the teams and cases where you could run into. But how do you go forward? What kind of things do you then structure to actually get to somewhere better? So I came up with some things that make sense in my head, and it doesn't even matter what it is, it's just that it's consistent. You can apply it to different teams, so they can span widely. I'm trying to cast a web here that can catch and help everybody in some way. So it's got to be able to be kind of generic and lowest common denominator and be able to really make it obvious how things are defined and going. As part of that, I came up with some terminology and things, central to which are stacks. A stack to me is a definition of some application or app suite. It could be essentially a single application that's just powered by a bunch of little microservices that are being all updated independently. Or it could be a single monolithic thing that is not at all more than one thing, but at least you can still start defining that, like saying, here's the thing, and at some point if you manage to split out a microservice, okay, it's still on the stack, now it's just a separate service. So a stack consists of one or more services. And a service is really just something that wraps around software that does stuff. So in my case here, I might have a service for Jenkins, where that service knows how to deal with Jenkins, but it doesn't opinionate it yet. The stack adds the opinionation to where this Jenkins for me is doing CI. The same Jenkins for somebody else could be doing CD. Of course, it's still Jenkins. You probably still want to be at the same version level at each point so that you know what you're doing, what vulnerabilities you have. So you're trying to make it generic and fit it to the different levels as best as you can. So services are grouped in stacks. And then you have environments, which can be grouped in tiers. Tiers would be your dev, QA, and production. So where you have usually different things at the different levels, to where in dev you might be just in dev 1, which is an example of an environment. you might just have a service that's stubbed out or mocked or something like that. It's not calling out to a third party at all, it's just returning some test data. So you can configure that at the dev tier, and then whether you have dev 1, 2, 3, 4, 5, they're all configured the same way. And if they need to be configured individually, well, then you configure it at the environment instance level. So that's things like, okay, I need my dev 1 to be using a particular web service or a particular port or who knows what it is. But it's at the environment level as opposed to the tier level, which is everything in dev, everything QA, everything prod. At each place in here, you might be pulling in resources, oftentimes secrets. So username, passwords, and things, which again might be set at a stack level if it's always the same. It might be set at the tier level if it differs only between dev, QA, and production. And it might be specific at the environment level, like use my certificate for this particular URL that's behind our QA environment. So stacks, services, tiers, and environment instances. The way GitOps promotes change, and specifically the way Hobo GitOps promotes change, is by having an environment manifest in which you're defining your application in some sense. Not the app code itself, that's somewhere else. But when it's packaged up, when it's built by your CI system, there's something you can refer to, a Docker tag or a version number somewhere in an application that okay, we need to get this thing out of the artifact repository that matches this tag and then plug into it. That's in the environment manifest. And the deploy jobs in a CD Jenkins knows how to take that in, read it, find the things, and deploy them to the corresponding environment. When you're hacked with something inside dev, you pull requested from dev to QA. This could be from your dev environment, dev 1 environment, to your QA 2 environment, or whatever it is. It just models the flow of where your stuff is going when. And it's always representative of what's in an actual environment. Ultimately, it's just this hobo operator, which is in Jenkins, is watching and triggers something. Whatever is going on over here is not the job of the DevOps team, which is a bad word in some places, but ultimately whoever is working on this stuff just provide the foundation, the infrastructure, the structure, the stuff. But the developers fill in what it means to them and how that stuff gets deployed. Although you might also have archetype level, applications where we know this is a Java microservice. So it's always going to be deploying the same way. It's going to be different applications, but it's a Java microservice. We know how to deploy it. So that logic is floating around out there somewhere, and it's getting plugged into these CD Jenkinses through GitOps, and stuff gets deployed. So this is an arbitrary stack that some team is deploying to their environments to serve an end user. But how does that system itself get maintained? Come on, there we go. So the previous slide essentially is this corner of the diagram. This is at Team X. They're doing their thing. Who knows what it is? They're doing their thing. This thing itself is essentially a Hobo GitOps stack, which can also be serving other teams. In the main scenario where I've used this, we were on an architect product team, APT, and we were essentially the DevOps team, but not really because there were a lot of other people involved in it, but we managed these stacks. So we had one stack which was just a CD Jenkins. It just helped teams deploy their things. And we had a CI toolchain, which was a different stack, which also consists of Jenkins, but added in a Nexus and a Sonar. And then we deploy those into our dev tiers and into our QA tiers and into production tiers where it would be actually serving all the teams equally. For smaller environments like dev and QA, it might only be 1 or 2 tenants that go in there and actually test things out. And then when we're happy and it looks okay, we deploy it to production for all the teams, both the Team X and ourselves and the GitOps structure. So these guys over here are managing what goes in here, and this guy down here is managing what goes in here. That was the pickle. Because at some point, you need to be setting up something so that your automation knows how to do its thing and deploy things. This got built into place to where there was a CD Jenkins that was managing the CI Jenkinses, and one of the CI Jenkinses was managing the CD Jenkins. That gets kind of quirky. It worked, but you really want something hopefully better than that. So, going beyond Hobo GitOps, the next thing was to try to figure out how to solve this chicken and egg situation. So, the APT has their CD instance, and the APT has a CI instance. Which came first? How do we put it there? How do we maintain it? If everything explodes and goes down, how do we build it from scratch? Which gets set up first? This thing over here probably builds the Docker images that powers this guy. Do we still have those? Do we need to recreate them? If so, how do we do it? Well, if this one is available, do we have all the infrastructure set up over here? Can we actually deploy this yet? Are the manifest repos in place? It's very... So how do we bootstrap in the first place to be able to manage this intelligently and with fewer quirks? Come on. There we go. All right. So I came up with a second workspace. The first one that was just Hobo GitOps was just a modern Jenkins workspace. It's open source. I just picked up an existing tutorial in Fancy Jenkins and adopted it, added a bunch more stuff to it, made it cool and shiny and neat and reusable. And now there's a whole new thing. This is more better aimed at the original concepts of stacks and services and teams and resources and so on. And it, again, just kind of tries to model what you have going on inside an actual workspace you can run locally, either if you have it's running using micro K8s, so it gives you a full-fledged Kubernetes locally. But whether you run it directly with micro K8s or if you want to put it inside a Vagrant box, the workspace gives you that option. It's modular in that every time there's one of these little icons, it's indicative that that's actually an external Git repository that you pull into the workspace to fit your particular case. This thing is not Jenkins specific anymore. Hobo GitOps with modern Jenkins was. But in this one, if you wanted to use GitLab or Bitbucket or something else instead, that's fine. It's okay. Because all those ultimately are going to be grouped inside, wrapped by services, grouped in stacks, and so on and so forth. And these things try to model that. So in this particular workspace situation, continuing with the past example, I would have two stacks. One that's my CI stack, which consists of a Jenkins, an Nexus, and so on, and a CD stack, which just consists of a Jenkins. Both of them are built off the same generic fundamental Jenkins, but may vary in what plugins they use and how they're configured and so on, which is the opinionation and config that the stack then adds. Finally, something that was on the previous slide was the new concept of teams. This is sometimes there's just one team. It's you. If you're the DevOps team, and that's what you're doing, okay, that's just you. It's your definitions. But this continuous workspace is going to be a thing that you can pull down, whether you're at one company or another. So your team is going to be your unique config. It's going to define, okay, which stacks are you using? Which tiers do you have? What environments do you have? And potentially some added complexities, like whether are you using your stacks in a way where it's actually one per tenant in some way. It gives you a lot of layers and nesting and things to really kind of help define how your enterprise looks like. And then ultimately, the idea is that this will represent your entire infrastructure, but it can do so in a single workspace locally. And if you really wanted to, you could just say, okay, I have this stuff, I've put everything in my manifest repositories, I happen to already have some sort of, GitOps operator, be it Hobo GitOps or something else. I've updated my manifest repositories. Okay, make my infrastructure look like this. Do the thing. All right, cool, great. How do you do the thing? So there's a bit more to the continuous workspace, insofar that there is actually, There is the services, and there's the stacks and so on, and there are the manifests that you deal with that define how all this stuff works. But there's also a local tier inside this continuous workspace. The local tier is what is powered by micro K8s, so that you can actually have your entire infrastructure, and like all of this, in a local variant on your laptop, inside this thing, all of it. You might not want all of it unless you have a particularly beefy laptop. You don't really need 100 Jenkins Masters because you have 100 teams. You can just experiment with a few. The deal is, you set it up. You might go from some open source hubs, like some repositories that we might make available on GitHub, that set out, okay, this is how we, with the continuous workspace and Hobo GitOps and so on, define the basic most version of Jenkins and so on around Nexus. And these are external, products that already have their own Jenkins Docker image and their own process and so on, and that's fine. This is not trying to replicate what they're doing. This is just lightly wrapping it just enough to work inside the system, while also giving you the option, if you so choose, well, we really need to fundamentally change something inside this Jenkins instance, all this microservice for Java and so on. It gives you the option to pull down these examples to play with locally. But then if you want to make it your own, you can fork these things and put your own unique things inside your organization's repositories, which might be Bitbug in this case. So that you have your unique version of it now, your unique service, Docker Jenkins. Maybe you have some SSL cert that you need to put in there. That wouldn't go anywhere else. That would go in your, fork of it. So you have this local tier. You can spin up things and test things. You have environment manifest so that you can GitOps all the things. But then how do you execute it? How do you stack it started? And that's where this bootstrapper comes in. That's the secret sauce. This bootstrapper is an executable and just a little bit of the glue code that so often is what you're missing at an enterprise, because you can pull in all these tools, Jenkins and Sonar and Nexus and Ansible or Chef or all kinds of tools, but you still generally have to have some way of tying them all together that's unique to you as an enterprise because of the different applications you have, the way you have team structures, your unique constraints because of legal requirements. Who knows? There are so many things that affect how you glue all these tools together. That teeny tiny bit of glue code, the least that you can get, goes into this bootstrapper. So this thing knows how to read your modular components that make up your enterprise and how you're deploying things with Ansible, your resources, your Kubernetes clusters, your Docker repositories, all the things. It doesn't contain any of these. These are still referencing external Git repositories where you're actually developing all these things. This just brings it all together and then decides, okay, I am ready to deploy my thing. I have nothing on AWS or Google Cloud or whatever it is. I'm setting up my infrastructure from scratch, and I have modeled it locally. Okay, executable, do the thing. You feed it some credentials and things. It does not contain Ansible or logic or anything like that. It just knows how to call into it. The actual deploy logic lives with the services and the stacks, and hopefully will come in from the actual external vendors that provide these tools in the first place. You don't want to rewrite all the things. You don't want to reinvent the wheels. You just want to be able to say, there are 4 wheels on the car, and this is how fast they spin. Like little things that are unique to you. So this thing doesn't contain Ansible. It just knows how to call into Ansible or Helm or customize whatever is powering these services and stacks. And then actually say, okay, I'm going to combine my definitions with my target environment, my hosting. Go do the thing. At which point you now set up your DevOps infrastructure, your CI/CD stacks in your live environment. But this is where it gets fun. That is not the only thing the bootstrapper does. That is what the bootstrapper does when it's in its egg shape in your local workspace. But you can also build and version and deploy this thing so that your orchestration, your CD inside this live environment knows how to get it and use it to actually deploy the end user things. In this case, on the DevOps team, that might just be more Jenkinses, more Sonars and Nexuses. But this could just as well be an actual end-user application that runs some front-end service on the web. So this orchestration process, whether it's Hobo GitOps or some other CD thing, is now responsible for doing it, but it works the exact same way as it worked in your local workspace. So now it's a chicken, but it's the same thing. You know, it lives in here, it's more formal. The normal operations is that, you know, you have your actual visible infrastructure and all your monitoring doing the things. But if for some reason everything just explodes, your infrastructure is gone, Google Cloud is down, AWS Cloud is down, you're trying to rebuild from scratch. Well, you still have the egg, you just point it somewhere else and do the thing again. And then it sets up your CD, and then the next level over is actually setting up your application and so on. You can also build in little ad hoc things like, I want to toggle a switch that sends me into maintenance mode. Okay, just run the little thing that triggers that, which is the other context in which you can run. You can hook this up to ChatOps. So where you're on Slack or Teams and whatnot, and you know, we have a serious emergency going on, into maintenance mode. Okay, I'm just going to tap on my keyboard and tell our chatbot, hey, set the thing in maintenance mode. Or deploy the thing to DR, just toggle it over. So whether you're doing it from your local workspace, whether you're doing it in your live environments, or even if you're doing it on ChatOps, it's all using the exact same thing. It's the chicken and the egg at the same time. That's what I thought was a cool angle on this, because it finally solves the problem I've struggled with for years and years. Okay, take a deep breath, take a sip, and let's dial it back a bit, because that was a lot of diagrams and a lot of complexity. And I could probably talk about this for a week straight because it's exciting and I'm a GitOps nutcase. So, all right. In short, you can do a lot, but it varies a whole lot based on how your environment looks like. Are you in AWS? Are you in Google Cloud? Are you in Docker or Kubernetes? Do you have 3 teams that are kind of like mostly doing the same things and they just have one Jenkins Master each and some Ansible that deploys their things? Okay, great. Do you want to take that to the next level if you're growing? So, who are your hobos? What do they want? What can be shared? When Alice makes that really cool, awesome thing that lets her go to the next level with Kubernetes and GitOps, great. Have her formalize that within some framework, like all the stuff I've just been talking about for a little while here, that's powered by GitOps, and then share it with the rest of the class. Make it work. Make it awesome. Come on. There we go. And arrive at the future. At some point, probably never, realistically, the whole enterprise, no. Unless you're one person running one application forever, it's probably never going to be done. But you can always be on the path to the future. So, will you become a productive member of Hobo Society? Guess we'll see. Thank you.